The question is the cost of optimal binary search tree for the identifier set A1, A2, A3 is equal to do if while with P of 1, P of 2, P of 3 are given as 0.3, 0.2 and 0.15, and Q of 1, Q of 2, Q of 3 and Q of Q naught should be given, and Q naught is Q naught Q0 Q0 is given as 0.05 0.05. Q0, Q1, Q2 and Q3 are given as 0.05, 0.15, 0.1 and 0.05. So here we have to find the cost of the optimal binary search tree. With this identifier set, there are we can construct 3 binary search trees. 3 binary search trees with the given identifier possible with the given identifier set would be do if while. If, do and while. Here it would be Q naught. This would be Q1. This is Q2. This is Q3. And for this would be Q naught, Q1, Q2 and Q3. And one more possible binary search tree would be this one, while, if and do. For this would be Q naught, Q0, Q1, Q2, and this would be Q3. So these are the possible binary search trees for the given identifier set. While calculating the cost, we have to for queues we have to take level minus 1, and for p's we have to take the level. For example, for this one Q naught will be multiplied by 1, Qt will be multiplied by Q1 will be multiplied by 1, Q naught Q0 would be multiplied by 1, Q1 will be multiplied by 2, Q2 and Q3 will be multiplied by 3. For this and for multiplying p's, we have to consider the levels. That means for this P of 1, P of 2, P of 3. 2 into P of 2, 3 into P of 3. So for this also, all the Q naught Q1, for all the Qs, here the level would be 2, and for P1, for P1 level is 2, and for P2 level is 1, and for P3 also level is 3. So if we calculate the cost for these 3 trees, for this tree the cost would be minimum, and the cost is 2 into 0.3 plus 1 into 0.2 plus 2 into 0.15, 2 into P1, 1 into P2, 2 into P3 plus 2 into Q1, because all these are in the same level. So 2 into 0.05 plus 0.15 plus 0.1 plus 0.05. So if we calculate this, if we simplify this, we will be getting cost as 1.8. So here Option A is the correct option. If we calculate the cost for these two trees, it will be more than 1.8. So the minimum possible cost is 1. Minimal cost of optimal binary search tree is 1.8. So your correct option is option A. The number of articulation points and biconnected components for the following graph are. Here a graph is given and we have to find the articulation points and biconnected components for that particular graph. In order to solve this problem, first of all we need to know what is articulation point and what is a biconnected component. Articulation point is nothing but a vertex deletion upon which disconnects the graph into two or more components. So if we see this particular graph, we can say the articulation points can be one articulation point. Why? Because if we delete 2, the graph will get disconnected into two components, this part and this whole part. So we can say 2 is one of the articulation points. In the same way, 3 and 4 also articulation points. Here 1, 5, 6, 7 and 8 cannot be articulation points. Why? Because if we delete 5, nothing, the graph will not be going, the graph is not going to disconnected into two or more parts. So we can say there are only 3 articulation points in the given graph. Those are, your articulation points are 2, 3 and 4. So here 3 articulation points are there. Now let us find the biconnected components. So here biconnected component is nothing but a component in which there will not be any articulation point. So that is called biconnected component. If we see the graph, we can say 1, 2 is one biconnected component. Why? Because even if we delete either 1 or 2, the graph is not going to disconnected into more parts. So we can say this is one of biconnected component. The same way 2, 3 is also one of the biconnected component. The same way 3, 5, 3, 6, the 3, 4, 4, 7 and 4, 8. These are also biconnected components. There will not be any articulation points in these components. So we can say in total there are 7 biconnected components. So here the correct option is option C, 3 articulation points and 7 biconnected components.